have a couple of minutes for questions.
I was wondering, for your CubeSat application of having these superconductors, is there any sort of cryogenics that you would require in the CubeSat form factor?
That's a good question. We've been thinking about that for a little while, and I said, for instance, earlier that there's no power required for some applications. For around Earth orbit, we might be worried about sunlight hitting the superconductors and warming them up. We've done some back-of-the-envelope calculations that suggest that only a sunshade would be necessary to keep the superconductors cool. So that's what we might look at for the CubeSat option. There's also the potential of flying superconductors in small self-contained dewars. For larger systems, then if a sunshade is not applicable, then this is well within the reach of existing cryocooler technology.
So the little video we had about the modular spacecraft all comes together. Actually, it's very neat. But as I imagine it, the challenge there is that you've got 7 independent spacecraft together, whereas there's no way for you to transfer power or anything among between the spacecraft. So, and when you were, I'm essentially thinking about the docking problem, and so, and when you pushed as hard as you could, you still couldn't get them to touch each other. So, are you going to be able to tune the displacement between back in the semiconductor so that you can get them to use the potential to fall close to each other, but then actually bring them together to actually make them into a whole spacecraft?
That is definitely a possibility. Or there's certainly nothing precluding you from using the Flux-Pinned interaction for structural integrity of the system and then extending across some docking adapter. But now, there are ways to transmit power and data wirelessly. So you could put together such a system where the components never touch one another. You could build self-contained spacecraft that only have to transmit data back and forth. So there are ways around that problem, but I mean, my personal science fiction view is that you could build a space station with flux pinning that holds modules together and then just snake a tube across for the astronauts to go between modules. The actuation possibilities that I mentioned also offer the possibility of tuning that equilibrium so that you could establish this binding between modules in a non-contacting way and then bring them together slowly, which offers a good potential for a very failure-tolerant docking option.
It would seem to me that this application could be used as a space elevator. Have you guys looked into that?
What are you thinking of specifically?
Well, essentially building a space lift capability, but in an elevator form where essentially it's building from the ground all the way up. And you have the stiffness built in, and then you can adjust the stiffness in your elevator structure.
So you mean forming the elevator structure out of the Flux-Pinned links?
Right.
That's not something that we've considered yet. I think that since the stiffnesses we're talking about are, they're great for space applications, but maybe not for, I don't think the stresses in the tether at the ground there might be too much disturbance there. It's not something we've considered or looked at in any way.
The geometry would be very similar compared to a very more complicated space structure. And you're just going one way.
Yeah, that's not something that we've looked at, but that's an interesting idea.
Instead of building energy structures.
Well, I'm happy to talk more about that later.
Just one more question. Is there, because usually in satellites you have some stringent magnetic lineage requirements. Is it to have all these magnets and all this? Is it something that is, in terms of order of magnitude, is it something that can be in line with these cleanliness requirements, or do you?
With, so are you worrying about ambient magnetic fields or magnetic fields influencing the
usually
space?
most of the sensors, they don't like this kind of strong magnetic field coming from the side. So is it something that you can control, or is it?
Yeah, that's a good question. A couple of points to respond to that. First is that these are DC magnetic fields we're talking about, so you wouldn't have to worry about the frequency content there. But there would be ways to design an interface such that you could limit interference. One of the potential designs we did some optimization designs, and this sort of hodgepodge collection of magnets here functions sort of like a Halbach array, where the magnetic field is, here's the magnetic field magnitude of that, but it sort of extends out towards the superconductors, but it's very limited wherever your spacecraft bus would be. So we could put these together in such a way to limit those effects.
Okay, I'm afraid there's no time for additional questions, so once again, thanks for the